So do we have two curves? Yes, no, maybe. That's easy, two functions. So do we have two functions? Yes, got one here, one there. We want to find the volume enclosed by the two curves. We want to revolve it about the x-axis. I'll put another restriction here. We want x to be greater than or equal to 0, and y to be greater than or equal to 0. So x greater than or equal to 0 could be anything. Likewise, this way could be anything. I would like to find a point of intersection. Do we know how to find a point of intersection in this case? Okay. The only way to do it here is to directly go to a starts with the letter C, ends with the letter R. What do we need to find the point of intersection? A calculator, because we have a cubic polynomial. If I set x cubed plus 1 equals 3x squared, I want you to come up with the solution. The only way you'd be able to do it is to rewrite it as x cubed minus 3x squared plus 1 equals 0. Do you know how to solve that? Quadratic formula is easy, but it only applies for quadratic functions. That's not a quadratic function. That is a cubic function. That degree polynomial can't do it, right? So we need a calculator. Before we even go to that, if you have to take a guess, is there a point where those two possibly could meet? Somewhere, anywhere? Want to take a guess? No? Did you graph it already?
Yeah.
Okay. I'll give you a second to graph. I'm going to insert maybe 3.2 something. No, it's off. Are there 2 points of intersection? I doubt it. There are 2 points of intersection.
Yep.
Both greater than x greater than 0. One of them should be negative.
There's negative.
Yeah, one of them has to be negative. We're only looking at bigger than or equal to 0, greater than or equal to 0 for both x and y. I'm under the impression that it is going to be somewhere close to 3. I could be wrong.
Is it like 26?
It's not going to be close to 3. It should be under to pivot or under one, something like that.
The X?
Yeah, X value.
Yeah.
So you can use your calculator and come up with an intersection. The first function is a parabola, that is easy. So it's just that. The second, on the other hand, is a cubic function. The cubic function looks like this, yes? And you are adding one, so it shifts up. So, one. That should be your curve. I have restricted my enclosed area. X greater than or equal to 0. Y greater than or equal to 0. That is my point of intersection. That doesn't matter because there is not another point of intersection. All I care about is that part. What is the X value?
0.65.
0.65. Y value?
1.6.
1.28. Okay. Now, we want to spin this enclosed area about the x-axis. It does help to, put this picture on this side. Looks like a knife. Sort of, right? Well, something like that. Eventually, you don't need this part at all. You can come up with the answer just by looking at those two. I'm doing it for you. We are spinning about the x-axis, yes? So the circle, two of them, right there. Do I have myself a washer? Yes, I got a washer, correct? Okay, so that is the area of the washer. So I have two radii, plural of radius. So one of them is right here, correct? The first radius. The second radius, outer radius, is right there. Do you agree? Inner, outer. Something like that. Or just leave it. I'm just zooming in so that you can see things better. What is strip? So there is my strip. Why am I placing it vertically? Oh, really trying to find why. Yes. dy or dx? You're just making up letters. You've got to make, pick one. Is it dx or is it dy?
X.
Where's the sound coming from? What's your name? I forget.
Noah,
Noah. So why dx?
because we're taking we're revolving around the x-axis, and since the strip is going vertical, it's the thickness, so we take dx.
Very good. So the disk is revolving. We are spinning about the x-axis, and if you want a volume, you've got to move it along this way. It's moving along the x-axis. So if it's moving along the x-axis, the thickness is along the x-axis. So the strip is delta x, good, or dx, up to you. Let's call it dx. Because we'll be using that in our integral. So I've got dx there. Whatever you put in here must be a function of what letter you pick. X. Very good. X. And from last time, I wrote outer radius of the area of the circle obtained using the outer radius and inner radius. In other words, area of outer circle minus area of inner circle. From here all the way to that curve would be the outer radius. Inner radius. Do you agree? Outer, inner, yes? Okay, what is the formula from last time? What did we do with the two areas? Once we identify outer radius and inner radius. Anna,
Wouldn't it be outer radius squared minus inner radius squared?
just the radius.
Yeah.
Pi times outer radius squared minus inner radius squared. Caleb, do you have an answer?
What you said.
Okay, so pi times outer radius squared will give me the outer area. Inner radius squared times pi, area of the inner circle. Well, you have an outer circle, you have an inner circle. Subtract, what do you get? You get a washout, correct? I know the limits of integration 0 to 0.65. Outer, what is the outer function? Outer in the sense one on top. We call it outer inner because if you go to the other axis, one's going to be outside, the other inside. So, which is the outer circle?
Cube is x cubed plus 1.
X cubed plus 1, one that's going this way. So, the radius of the outer circle moves along that curve. What is that curve? Y equals x cubed plus 1. What is the radius of the inner circle? Well, as you move from 0 to 0.65, the inner radius is traced by the second curve, which is 3xy. So, x cubed plus 1 squared minus pi times 3x squared dx. So 0 to 0.65 and pi x cubed plus 1, the entire thing squared dx minus integral 0 to 0.65 pi times 3x squared, squared again. 3 squared is 9, x squared raised to the power of 2 is x raised 4. Common mistake. Come all the way to this step and forget to square. Put a side note, don't be that person, don't make that mistake. I've seen way too many students make that mistake. That's just integration. Go ahead and integrate for me.
The limit is
Okay.
and you usually.
So we want to integrate. The second integral is easy. I strongly recommend that you know how to integrate manually. Because intentionally I'll do something on the exam where you cannot use a calculator. So know how to integrate manually. First integral, second integral, both of them have a pi in it, so I'm going to take pi out. Second integral, 9 constant. So keep an eye on this. What is the integral of x raised 4? Very good. At this point, you should know x raised 5 over 5. Great. Can I erase this part? What is the integral of the first function x cubed plus 1, squared? In order to do this integral, you've got to know what technique to use. One might say, well, I could go for u substitution. Well, the problem is, if it is u substitution, if u is x cubed plus 1, what is du over dx? Derivative of this, 3x squared. Do you see 3x squared in this integral? No. So clearly, can't do u substitution. That leaves us with only one option, which is FOIL. Easy to FOIL this one. X cubed squared plus 2x cubed plus 1. Integrate that. As I went around, the most common mistake was right there. What is x cubed squared? X raised 6. Still, some of you wrote it as x raised 9. You multiply these two exponents. So 0.65 integral of x raised 6 is
X raised 7.
x raised 7 over 7 integral of x cubed. X raised 4 over 4 integral of 1 x. And then I've got minus x raised 5 times 5. Lower limit 0, upper limit 0.65. Anytime you have an expression of that sort and the lower limit is 0, forget about the lower limit, because when you plug it in, it's going to go away. Good? As long as you have a bunch of x terms here, algebraic terms, lower limit is 0. You don't have to worry about the lower limit. So plug in the upper limit in the calculator. The answer 0.537 pi. That's what I thought. Okay. Are we clear? So we cut the strip this way, we rotated it about the x-axis, yes, to get some order. We're going to take the same shape and do the next part. Can I erase this? I'm doing it side by side so you can see what's happening. So that is the x squared curve, and then we've got x cubed plus 1. Trying to get the perfect curves here, but okay, that would do. I shouldn't get too OCD about this. So the enclosed area doesn't change. Do you agree? Yes, it's still this one. I want to find the volume when I spin it about the y-axis. Good. How would we go about doing it? Or where should the strip be? Should it be horizontal? Should it be vertical?
Horizontal.
If you put strip right there, good. You move it and I want you to find the volume. Set up first. Let's see if you can set it up. The strip is moving up and down. I want you to set it up. So if we need an outer radius, we need an inner radius. So now people, you have to think and sure, Desmos, GeoGebra, they're all calculator, they're all great tools to visualize and stuff. Draw things out, it does help. Okay. Do we get the part that the disk method is a special case of the Washer method? When does it happen? If the inner radius is 0, correct? Or the outer radius is 0. In other words, you don't have area between two curves, you just have a curve, correct? Okay. I'll put a strip here. Yes? Do I have a second curve over there? Or do I just have one curve? I went around, you all used Desmos, one was blue, the other was red. Do I have just one curve or do I have two curves? I've had 4. Two curves? What are the 2 curves? I can't hear you. I heard something, but louder. You said why?
The y-axis and then the other function?
And the other function, okay. Y-axis and the other function. By other function, he means y equals 3x squared. Agreed? Okay, if one is the axis, one curve is the axis and the other one is a function, do you actually need the Washer method? You have area under the curve, you spin it, correct? What method is that? Disk. Okay. Hey, enough, we would. No, no. Make it. Should I just use this method? Should I just use Washer method? Well, you've got to use both. As this strip moves along, does it always move along the axis? Alison's going like this. Why is that, Alison?
Because the second, if it keeps going up, it will reach that.
Okay, eventually there comes a point where the second curve is going to start showing up. Well, what is that point? This point right here is 1. The curve is y equals x cubed plus 1. This is y equals 3x squared. Good. Until that point, the strip is moving along the axis and one curve. Agreed? So I'm going to call what is the volume that I would have here as V1. Good. But my point of intersection is right there.
Oh, no, not.
Okay, right there. 1.28, was it?
Yeah.
1.28. Good. Now I have 2 curves. One is the top curve over here. The other is that part. Agreed? You are spinning about the y-axis. So you pretty much have that. And then you're going to form one for the outer one. So when you put the strip, horizontal strip, one would touch that, agreed. The other outer would be that. Yes, no, maybe. Inner, outer. When you spin, this part right here is going to get spun around the y-axis. Okay, so that is what's going to form the water. Another way to look at it is find the volume below this and subtract the volume of this part. Same logic, right? That's exactly what I'm doing. Finding the volume below this and then taking away the volume there. So the inner radius is here, outer radius is there. So my strip is moving along the y-axis. So should I use dy or dx? Dy, okay. As I move from 0 to 1, I don't have that second curve, it's just the axis. It'll just be this method. I have only one radius. What is that one radius? That it is traced out by this curve. So pi times whatever value I have, arbitrary x squared. But I can't have a function of x and integrate it with respect to y, knowing the fact that x is not a constant. I've got to rewrite this. We've done this before. Go back to the original function. I'm dealing with the black curve that's right here. Y is 3x squared, which would mean x squared is simply y over 3. With me so far? Okay, so 0 to 1 pi times y over 3 dy. What are the constants in that integral? Pi 3. Let's pull that out. Pi over 3 comes out. And integral 0 to 1. Y dy. What is the integral of y? Integral of y. Y squared over 2. Plug in the limits, lower limit doesn't matter. Upper limit 1, so that would be 1/2. So pi over 3 times 1/2, pi over 6. So my first volume is pi over 6. I'm going to call my second volume as V2. At that point, I've got two curves. One is this one, the other is that one. We call it outer, inner, because if you put a strip, this curve is outside, that curve is inside. Yes, that's where the outer, inner part comes into play. I erased the picture, but if you revolve about the x-axis, look at it from sideways, the top one is outer, the other one is inner. Good? Easier to see in the y-axis case. Okay, I want to find that second volume. First one, straightforward, this method. Because one of the curves is 0. No, sorry, axis. Or x equals 0. Nothing wrong with that. But the next part right here, you have two curves, and one of them is 3x squared, the other is x cubed plus 1. That's no biggie. Okay. And that happens only between 2 points. What are the 2 points for y? Louder.
1 and 1.28.
1 all the way up to 1.28. Okay, over here, I've got the outer radius, I've got the inner radius. So, inner radius, outer radius. Well, as you trace, the outer radius is defined by that function. Outer function is still 3x squared. Agreed? I've done that work here. If y is equal to 3x squared, x squared is simply y over 3. The outer function corresponds to that curve, so this is simply y over 3. If R is confusing, you could put x out, x in, right? X out is right here, tracing this curve, x in is the inner curve. Okay. I can't have an integral with respect to y in the function that is in terms of x, given the fact that it's not a constant. How do I find that? The inner curve. Waiting. I showed you how to find the outer curve. So inner curve. Still waiting. In this method, you can look in your notes. If we revolved around or about the y-axis, we solved for x. We wanted a function in terms of y. Do you agree? If it is about the x-axis, life is easy. I'm just integrating. Same logic. This part, it was this method solved for a function in terms of y. Good? back here, AutoCAD, solve for a function in terms of y. Good,
Cube root one minus one.
louder, Caleb, louder, make me proud.
Cube root y minus one.
Cube root y minus one. I simply have to solve for a function of y for that curve. I have y equals x cubed plus one. Yes, which would mean that is the inner curve. So let's put x in there because I'm referring to that cube function. Y minus one would be x in cube. Want to solve for x in simply y minus one raised 1/3, which is the cube root of y minus one. Good. Okay, take that, plug it in here. Pi times y minus one raised 1/3. Let's see if you paid attention. I can rewrite it as y minus one raised 2/3. Good. Like number two. 2/3. I guess I'll move from that. So V2 is integral 1 to 1.28 pi y/3 dy minus pi 1 to 1.28 y minus 1 not 1/9, it's 2/3. Integral of the first term, pi/3 is a constant. You have y²/2. Pi is a constant. If you integrate the second term, you have 3pi/2 times y minus 1 raised 5/3. You can integrate that home. Now I know. Okay, lower limit would make that one 0. Degree 1 minus 1, 0, it's gone. When I plug in upper limit, 1.28 minus 1.28, so negative 3pi/5 times 0.28 raised 5/3. Do the same over here. Upper limit 3 times 2, 6. 1.28 squared minus lower limit. In this case, you can't simply put 0. The lower limit is 1 minus 1 squared. So pi/6, what do we get? Not done yet. What answer do we get? Wait. 1.28 squared. No times. Raised to the power of 2. 2 raised 7. That's 1. 2 raised 14.
1.638.
6/3, okay, minus 1. The other part minus 3pi/5, and 0.28 minus 5/3. I'm sure it's a pretty good number.
0.12.
0.12. Okay, this is 0.63 pi/6. 0.12 times 3pi minus 0.36 pi/5. What do we get? 5 times 0.63. 3 point something minus 6 times 0.36, 1.8 something. So approximately 1.2 pi over 30. You can do this calculation at home. Add this to that to get the total volume. The total volume when you revolve about the y-axis is V1 plus V2. Pi over 6 plus 1.2 pi over 30, approximately, the answer is 6.2 pi divided by 30. And put it in the calculator. If you want to reduce it further, it is approximately 0.2 pi. Approximately. So, do we understand? Got to think. Water method happens when you have two pairs. This method is a generalized, a special case of washing method. Okay.